Hello everyone, this is Heidi Tricia Santos. So for this video, we will be answering one of the problems in triple integrals in spherical coordinates, which is number 3 on page 18. Let's begin. So here is the problem. Evaluate triple integral 2yz dv over the region E, where E is the region below x squared plus y squared plus z squared equals 16, and inside z equals square root of 3x squared plus 3y squared that is in the first octant. To formally start our solution, let's write down the given notation. Now, we'll proceed with visualizing the region through a 3D graph. As you can notice, the violet region represents x squared plus y squared plus z squared equals 16, while the blue region represents z equals the square root of 3x squared plus 3y squared. If we try to look at the graph, it looks like we are trying to find the volume of an ice cream cone. However, we should not forget that we are only interested in this part of the region located in the first octant. So it's not totally the whole ice cream cone. Now that we have seen the sketch of the region, let's proceed with identifying the limits. Since we are at triple integrals in spherical coordinates, we must know that dv is equal to rho squared sine phi d rho d theta d phi. Hence, we must get the range for rho, theta, and phi. Well, identifying limits for rho and theta will be just easy. For rho, the limits will be from 0 to 4 since rho corresponds to the radius of the sphere. For theta, we will have the limits from 0 to pi over 2. We have used the mentioned condition that we are only dealing with the first octant. Meanwhile, getting the limits for p can be a little complex because we will try to obtain it by some manipulation. Remember that phi is the angle from the positive z-axis that we rotate through as we cover the region. So since we are concerned with the region inside the cone, then we must get this specific range. In doing this, we will be using some of the conversion in spherical coordinates. So here is the process. So for phi, the limits will be from 0 to pi over 6. Now that we have settled the limits, let's write down the more defined notation. Notice that as we are dealing with spherical coordinates, 2yz was also converted. So let's just further simplify this and integrate the innermost part. Since we are integrating with respect to rho, we will treat this as constants. So the integral of rho raised to 4 is rho raised to 5 over 5. So evaluating 2 rho raised to 5 over 5 sine squared phi sine theta cosine phi from 0 to 4, we will have this. However, since evaluating the lower limit will just give us 0, let's just focus on evaluating the upper limit. So we have arrived at having the double integral of 2048 over 5 sine squared phi sine theta cosine phi d theta d phi, evaluating from 0 to 5 over 2 and 0 to pi over 6. Again, since we are integrating with respect to theta, we will treat this as constant. So the integral of sine theta is negative cosine theta. Now, we need to evaluate this from 0 to pi over 2. So we'll replace theta with pi over 2. After the minus sign, we'll replace theta with 0. Now, let's just further simplify this. So we are left with the integral of 2048 over 5 sine squared phi cosine phi d phi evaluated from 0 to pi over 6. From here, we will undergo an integration by substitution. And here is the process. So by using the result from our u substitution, we will be left with 2048 over 5 u squared du. And the integral of 2048 over 5 u squared is 2048 over 15 u cubed. Now, we'll bring back the initial value of u since we will evaluate this from 0 to pi over 6. So here is the final process for evaluating this. That's it. The answer to the given problem is 256 over 15. So that's all for this video. Have a nice day ahead.